One second. Okay, hi everyone. My name is Parth,
Hi everyone, my name is Shriya.
and we are your revised now tutors today for IB Physics. So we're gonna go over a few of the practice problems that we had for topics 1.3, and we're just gonna go over some of the ones that we found challenging or some of the ones that were a little tricky to navigate. So let's go ahead and get going with the second number 3. Okay. So it says Lynn is driving home from work and finds that there is road construction being done on her favorite route. So she must take a detour. Lynn travels 5 kilometers north, 6 kilometers east, 3 kilometers south, 4 kilometers west, and 2 kilometers south. Draw a vector diagram of the situation and what is her displacement and what is her total distance. So before I do this problem, let's make a clear distinction. That distance is the total length of the path, whereas displacement is really just your change in position. So knowing that information, you can easily solve this problem. So this is not necessarily going to be perfect because I don't have a ruler with me, but I'm just going to draw approximately what I have. So let's say, one second, I have to use the annotate feature. Yeah. So this is the 5 kilometers north, right? And then we have the 6 kilometers south, 6 kilometers east. And then we have the 3 kilometers south. And then we have the 4 kilometers west. And then we have the 2 kilometers south. So this is basically the path that she went along. And so it's asking us to find a vector of the entire situation. So we have this diagram printed out. And basically what we can do is we can create a vector by connecting these 2 points and then figure out how much distance she traveled. So since distance is the easier one to figure out, I'm going to do that one first. So we have 5 here, we have 6 here, we have 3 here, 4 here, and 2 here. So simply distance is just the total amount you traveled. So that's 5 plus 6 plus 3 plus 4, 5 plus 6 plus 3 plus 4 plus 2. It's 20 kilometers traveled. And so that would be your distance. Whereas, sorry about that. Whereas your displacement is the total change in position. So if we started here and we ended up here, think about how much has been changed. So let's say you started at 0 and you ended at 2. So instead of rather taking a vector approach, you could simply just think about moving 2 kilometers to the east. So your displacement would be 2 kilometers each. And make sure that you make a distinction between what a vector and a scalar is, because the displacement has magnitude and direction, whereas a scalar just has magnitude. So that's number 3.
Thank you so much, Parth. I got the same answer too. So let's move on to vector addition, which is in question 8. Okay, so we're going to do question 8A and 8B. So here they've given you 2 vectors and you're asked to add them and then also subtract them. So you're given 3 meters per second east for V1, and for V2 you're given 4 meters per second and with a 30-degree direction. So you're given your magnitude and direction, which is exactly what a vector would need. So the first hurdle to cross is figuring out how these vectors look like, because they've obviously not given us any sort of diagram. So we have to draw it based on the length and the magnitude that they've given us. So for V1, I'm going to, okay, so for V1, it's 3 meters per second and it's towards the east. So if we look at our cardinal directions, never eat soggy waffles. V1 is going to look like this. And then V2 is going to be a little bit longer than V1, but it's also going to have a 30-degree angle. So I'm going to make it look like this. So that's V2, and it's not the perfect drawing, but that shows that it has like a 30-degree angle. So when we're adding them, we have to remember the head-tail method. So I'm going to erase this. Okay, so we know V1 looks like this, and it's pointing towards the east direction. And to use the head-tail method, we want to attach the bottom part, or the tail of V2 to the head of V1. So we know V2 is going to have an angle, and I'm just going to attach it like that, so that the heads and the tails of both are joining together. And then to find the resulting vector when adding these two, all we're going to do is we're just going to find the shortest distance between the tail of V1 and the head of V2. So in this case, that will be this. So we can write that as V, or the resulting vector. And you could also go ahead and figure out what the value of of V is, but the thing is, it's going to be a little bit difficult to do that because you're not given a right triangle, so you can't use the Pythagorean method. So what I'm going to do instead is I'm going to turn this into a right triangle. So this is only if you're asked to find what the value of V is. So I'm going to add that, so that way it becomes a right triangle, and then we can easily find what this value is. Okay, so we know that the value of V2 is 4. So this is 4, and this is 3. And we know for V2, it has an angle of 30 degrees, so we can say that this is 30 degrees over here. So simply to find this side and this side, we have to use trigonometry. So I'm going to say that the height is 4 times sine of 30, and then the width is 4 times cosine of 30, because that was the definition of the vertical and horizontal components that was stated earlier. So in order to find what V is, we have to basically just do the square root of 3 plus this value, which is 4 times cosine of 30, squared, plus 4 sine 30. And that would give us the value of this resulting vector. So once we compute that, we can figure out what this vector is. But in this case, if you're just given a diagram, you could just draw this and you'd be done. So now let's move on to 8b. Okay, so for 8b, it gets a little bit different because you have a negative in it, which means you're going to have to flip how V2 looks like. So all we would do is we're going to draw just what we've done previously for A, because all we do is change the signs. So that is V1, and this was V2 as per the previous question. Now we have to, this is how you add these two vectors, but we have to subtract them. So I'm just going to flip V2 so the direction's the exact opposite. So it becomes like that, and your resultant vector is this blue line. And here it's a little bit difficult to find the value of your resultant vector, but you would have to implement the Pythagoras theorem by adding an extra triangle that makes this look like a right triangle, which makes it easy to figure out what v is, what v1 minus v2 is as a value, since you're already given that v1 is 3 meters per second and that v2 is 4 meters per second. So this is just an overview of how you would solve these types of questions. And yeah, I think we can move on to the next question.
Okay, so I'm gonna cover 9A, I think. So you can scroll down to 9A, please. Okay, so it asks us to sketch and calculate the vertical and horizontal components of the following vectors. Before we even start solving this, that basically means that you're going to have to do the value of Vx and the value of Vy. And that means that you would have to do the value of V times cosine, the vector times cosine theta, and then also the vector times sine of theta. So in this situation, we have that V is 3.0 meters per second squared. So before I start this, I'm just going to create a X and Y axis so that it makes it easier to do it. And then this is my Vy, and then this is my Vx. And then I'm going to do it in another color so that you guys can see it. And then this is the vector that I have been given, right? So this means that theta in this situation is 30 degrees. And this is what V is. So we already know the vector. And in this situation, what exactly are we trying to find? We're trying to find the horizontal and vertical components. Once again, horizontal would be your X and vertical would be your Y, I believe. So let's connect those points so that we can get our Vx and our Vy. So the next thing that we would do is we would set up our equation that we have been given. So Vx equals 3.0, right? Because that's the vector that we've been given, the magnitude of the vector that we've been given, times cosine of 30. And when you do that, you would find that Vx equals 2.6 meters per second. Is that right? And make sure that when you're doing this, you are rounding to 2 sig figs. A reminder that when you multiply, you round to the least specific number of sig figs. So in this case, 3.0, we would keep it at 2.6. So we do the same thing for y. Vy equals 3.0 times sine of 30 degrees. And that means that Vy equals 1.5 meters per second. So in this, we really, really simply found it, and graphing it can make it even easier on you. Okay, if you can scroll down to 9B or 9C, we can cover one of those. Okay, so for 9B, I guess we're doing that one. So we're going to do the same thing in 9B, and we're going to create the X and Y axis. So let me do that very quickly. And then it says that we have the same magnitude, but we're changing the direction, or we're changing the angle that it's going at. So I'm going to change the way that the vector looks very slightly, right? It would look that way, and the angle would be 45 degrees. And we know that this is our vector V, so we can draw exactly what we need. And so that would be, in this situation, this would be the Y amount, and then this would be the X amount. And we'd set that up with the equations, just like we did last time. And so that would be v of x equals 3 times cosine of 45 degrees. And then vy equals 3 times of cosine of 45 degrees. And if you've taken pre-calculus, or if you ever even looked at the unit circle, you know that the value of cosine and sine of 45 degrees are actually equal to one another. So in any situation, if you weren't given a calculator, just know that the cosine and the sine of 45 degrees is root 2 over 2. But in this situation, since we're in physics, we're just going to round to the least amount of sig figs, and you would get the same answer, which is v of x equals 2.1 meters per second, and v of y equals 2.1 meters per second. So a good way to double check these answers is that when you have 45 degrees is that they would equal the same thing. So that is how you do 9b. We're going to review about 5 more problems. And we have an added tutor. Her name is Shreya. So the 3 of us are going to tutor a few subjects. So I'm going to start with 10C on the 1.3 physics problems. So just to be clear, the question number 10 says, sketch and calculate the magnitude and direction of the vectors that has following horizontal and vertical components. So Vx and Vy are the vertical and horizontal components. So it's actually asking us to find what the value of the vector is, right? So the first thing that I would do, what just happened? Okay, the first thing that I would do personally is draw my x and y axes, just so that it makes it more clear. And so we have 30 meters on the Vx. So it says negative 30 meters. So keep in mind that while 30 meters would go this way, a reminder that when you're subtracting or when it's the negative side, it would go the complete opposite way. So that's 30 meters. Whereas negative 30 would be on the other side. So this way. So let's say this is about 30. And then we're going to set the y1 to, I believe it's 45. And then we're going to draw the vector through the middle and then figure out where it connects. And then by doing that, we can connect the vector with the Vx line. And that is how we connect the vector. And so now what we'd have to do is we'd have to figure out, We'd have to figure out how to find the value of the vector. And so the way we would do that is we'd set up the equation and we'd use the Pythagorean theorem because we're trying to find this value. And the way that we would do that is, we're not trying to find that well. We're trying to find basically the value of the hypotenuse, right? So when we do that, it would be the square root of 45 squared, right? 45 meters per second squared plus 30 meters per second squared. And then you would get that v, the vector, for the magnitude of the vector is the square root of 2925 meters squared over second squared. Keep in mind, I forgot to add a meters per second here. That should be squared as well. And so then your magnitude of this would be 54 meters per second. But it's not done. When you only have a magnitude, you're literally only looking at a scalar. We're trying to find the complete vector. So in this situation, we'd have to set up the equation that theta equals arctan of Vy over Vx. What is our Vy in this situation? It's 45 over 30. But this question is a little different. This would be if the vector was on this side of the graph. However, this is not the situation. So whenever we're looking at the complete angle, it would be all of this. And so the reason for that is, it would be all of this, right? And So the way that we would find that is by simply adding 90 degrees, because this is 90 degrees. This would be a full 180. This would be a full 270, and this would be a full 360. So let's look at it that way. So arctan of 45 over 30 and plus 90. And so when you do that, you would get that theta equals 127 degrees. So simply your answer is, finally, I'm going to write it on this side. The vector is 54 meters per second at 127 degrees. Is that right? That's right. Right? Okay. So that is 10C. We will move on to the next question now.
Okay, so we're doing question 12B, and apologize for my shaky camera, but I wrote it out here because it's going to be easier for me to draw it. And so right now we are given the components of AX and AY, and we're going to draw the XY plane right here, right? And because we have no direction, which is like the angle measurement, right? It doesn't say like 30 degrees or 45 degrees. We know that these, we can assume that they run along, they don't even have a direction. So we can assume that they run along the x-axis or the y-axis respectively. And so right now we know that AX is 124 kilometers, and that's our first vector, right? And so we're going to draw it here. Let's assume this is 124 kilometers, our first vector. And then we're going to draw AY, and AY is negative. AY is negative 158, right? And so that's going to go down. And so we're going to start from the head of our last vector, our first vector, and we're going to draw all the way down, right? And this one's going to be 158 kilometers. If you want, you can draw a negative sign, but we already are doing it in the negative y-axis. And so this is a right triangle, right? And so we can, this is the vector that we want to find, this vector right here. And so if we're trying to find this vector, we're going to do Pythagorean theorem, right? So it's a squared plus b squared equals c squared, right? And if you rearrange that, we know c equals the square root of a squared plus b squared. And so our a is our x value right now. So what's our x value? Our x value is 124. So c equals the square root of 124 squared plus, what is our b value? Our b value is negative 158. So negative 158 squared. And negative, whenever you square it, it's going to end up becoming a positive number. So we're going to try to find the square root of that. Shriya, can you plug it in for me because I'm holding my phone?
Yeah, 1 second. It's 12B. I got 201 kilometers.
Okay, 201 kilometers. And so we're rounding it to a whole number because if you realize both of these are a whole number, if on the test or the quiz that Ms. Raja gives you, I would recommend maybe writing the decimal number to the side so she knows that you did the work correctly, and then round it for your final answer so it matches the rest of your vectors. And so here's our vector right now, right? Our vector magnitude, right? And so now we have to try to find our vector direction. And so direction, we're referring to the angle measurements that correspond with the vector that we just found. So if this is the vector that we've just found, this line right here, this, because this is going to be our direction. This is going to be our direction. And always remember that direction, if this is the XY plane, direction is always correspondent to the positive X section. So this technically is going to be our direction. So whenever we find direction, a formula to know, which you can plug your values in, but I always recommend to check it with, physical work, is theta, which is the angle or the direction that we're trying to find, right? Equals tangent -1, which is, if you put in your calculator, it's going to be shift tangent, right? Which also means tangent arc or arc tangent. And then we're going to put our y value, right? Which is what's our value? It's negative 158. So negative 158 over our x value, which is 124. And then we're going to evaluate that. Can you do that, Shreya?
Yeah, you get negative 51.9.
Okay, so we get negative 51.9. And so whenever you look at this number, just using what you know so far about geometry, we know that in an xy plane, right, around this origin, we have 360 degrees. It won't make sense to just say negative 51.9 degrees. You can if you want. She would probably take it, but if you do that, you're gonna have to put a direction on it. I feel it's easier instead to just subtract it. So we have 360 degrees in a total circle, right? We know this one, it says to be negative 51 degrees, right? And so if this is negative 51 degrees, 0.9 degrees, we have to subtract whatever this value is, right? The absolute value of whatever this is from 360 degrees to find how far away it is from the positive x. So we're going to do 360 minus 51.9. And if you do that, you get, Shreya?
Okay, let me plug that in. $308.1.
308.1 degrees. So this is our direction that we found for the tangent that we just evaluated. And so how are we going to notate that? If you want, you can just round it to 308. I would ask her though. I'm not sure how she wants us to round our angles, but let's just keep it in this form for now. So how are we going to write that? So we know that A is what we're trying to find, right? Because we had AX and AY. And so we know that tangent A is going to equal our magnitude, which is 201 kilometers, which is our unit, right? And at 308.1 degrees. Okay, yeah. Okay, so we're doing 14C. And so when we're doing 14C, we can see that it's saying negative of the tangent of F3 plus F2, the tangent of F2 equals tangent F. So first what I want to go over is what is F? F itself, right? We have F value, the F value right here. And F's value is 6 newtons to 60 degrees. And so if we're looking on the XY plane, we can kind of assume.
1 second. Move your camera up.
Oh, sorry.
Yeah.
Okay. So if we're looking at 60 degrees, we can kind of assume that 60 degrees is right here on the XY plane, right? So this is how our tangent's going to look. We know that this is 6 newtons, right? And so right here, if this is a positive, how are we going to find the negative, right? Because they're asking for negative F3. This negative F3 is going to be on the opposite side. So look at the XY plane. If positive X is on this side and positive Y is on this side, negative Y is on this side, it's going to be the opposite value. So if this is positive 6n, this tangent right here is technically going to be negative 6n, right? So that's something that we need to clarify real quick. And so whenever it says this, what we're going to do is if this is negative 6n, we already know what negative F3 is, it's negative 6n. And so F2, so we're starting off with this value, so we're going to have to start drawing F3 first, negative F3 first. So negative 6n, you don't even have to keep negative 6 on there because technically tangents, whenever you're writing their magnitude, you don't put negative. But I'm going to put there as it has a reference that it's not the actual F3. And so then we're going to do F2. And so F2, where are we going to draw it? F2 is right here, is 6 newtons at 120 degrees. So 120 degrees, if you're looking at this, let's assume that this is an XY plane. 120 degrees is going to move upward, right? Sorry, it's going to move this way because you're going to have a lot of space. So this way, right here. Because this is the degrees of the tangent it's going to be 120. So this right here is also 6n, and this is f2. Do you guys have any questions with how these tangents look?
No, got it. Thank
Okay.
you.
All right. And so right now we have this. What we're trying to find is this tangent right here. This is f, right? This is f. This is f2. This is f3, right? And this is f. That's what we're trying to find. And so right now we know that this is not a right triangle. I didn't put it on the xy plane because it's going to be too many lines and you guys are going to get confused. But we know that this is not a right triangle. So how are we going to break it down? We're going to break it down into its components. And so to break it down into its components, we need to know if this is f3, we need to know f3x, the x value of f3, f3y, and if this is f2, if this is f2, we need to know f2x and f2y, right? You know the x and y components of them. And so we're gonna draw these components out, right? And it doesn't matter how you draw it on your graph, just however is comfortable for you to solve it. So this is comfortable for me. And remember, all of your lines or components you want to find have to be parallel to your x and y, right? Because you want to form a right triangle. And so right now, we know that f3 right here, this is 30. It's 30 degrees. And we know that this on the negative side, this is also technically going to be, no, sorry, this side right here, because vertical angles, the rule of vertical angles right here, right, look at this. So the vertical angles right here, this is going to be 30 degrees. And right here, we know that they told us that this whole thing is 120 degrees. Okay, and we're trying to find the angle right here. If we know that for this tangent, this whole thing is 120 degrees, and this is a vertical line, this is our x coordinate, we know here, this is 180 degrees. So if our tangent right here is 120, we know that what's left over is 60 degrees, right? This right here is 60 degrees. So right now we know that this is 60 degrees. And so how are we going to find our f? So first we need to find our components. And so to find for this tangent, which is f2, right? f2x, the formula we're going to use is, oh my God, where's my pencil? Okay. Is we're going to do our magnitude, which is 6, right? 6. And then we're going to do cosine with whatever angle measure that we have. So cosine 60. And then we're going to do f3x, which is we have our angle measure. Okay, so we found this is the formula that we're going to use to find f2x. But we can't assume that we're going to use the same formula for f3x because check this out. So cosine, right? We know that cosine is ka and sine is so, right? Which means cosine is adjacent over hypotenuse and so is opposite over hypotenuse, right? And so if we're going to do cosine, let's see what happens. If we're going to do cosine, we're going to do adjacent, right? Which is our y value, right? Technically, this is the y value of our component over hypotenuse, right? And so if we evaluate that, we're eventually solving for y, which is not what we need for x. So let's see what's going to give us x. So let's seek sine. Sine is opposite. Oh, wow, this is our x value, right? And this is our hypotenuse, right? And so we're going to use sine. So what we're going to do is our magnitude, which is 6, with our sine. And then we're going to do our angle measurement, which is 30.
Wait, sorry, Chaba, quick question. How did x become sine?
Okay, so this is what we're trying to find, right? Of negative 6n.
Yeah.
These are the components that we're trying to find. And right now, we know that this is 30 degrees, right? And we know that this is 60 because this is the right triangle,
Yeah.
right? But I use this value right here.
Okay.
So what I also did cosine first, but then I figured out, just think about cosine, right? So if we're doing cosine of 30, we're going to do adjacent, right? This is adjacent right here. And this is our y value, right? So let's do adjacent. So let's say adjacent, right, over hypotenuse, which is 6, right? And so we're going to do cosine 30, so 6 cosine of 30, right? Of 30, and cosine of 30, right, equals what? Adjacent, which is right here, over hypotenuse.
Yeah.
Right? Cosine of 30 equals adjacent over hypotenuse. And so if we do that, whenever we do our hypotenuse, right, which is 6, our magnitude, cosine 30 gives us adjacent. And this is our adjacent value. But this is our y value, so we can't use it to find our x. We can use it to find our y, but this is our x value. This is what we want for our x.
Okay.
Right? But if you do 60, we can always do cosine, right?
Mhm.
We can do adjacent over hypotenuse, and that would give us our x value. Does that make sense?
Yeah. Just kind
So
of.
what happened was, because we flipped it over the x-axis, the position or angle wasn't changed, right?
Mhm.
Right? And so
Yeah.
it's always, most of the time, you're going to use cosine to find the component of x. But you can't always just assume that you're going to use cosine. It's better to check it,
Okay.
right? If you have time, at least. Okay?
Yeah.
All right. So because of what I explained right now, we get 6 sine 30, right? And so if we're going to do let's do y for f3y. So f3y is this value right here. No, f3y is this value right here, right? This is our y value. And so what are we going to do? Let's see what does cosine do? Cosine is adjacent over hypotenuse. And if I explained it right here, adjacent, right, is going to give us our y value. So we're going to use cosine. So our magnitude, cosine 30. So whatever function you use, right, whether it's sine or cosine, the opposite function, respectively, sine or cosine, will be used for the x or y. So if I use sine for x, I need to use cosine for y. If I use cosine for y, I need to use sine for x. Okay. And so for f2y, to find our y value right here, which is this is the angle that we have. So we want to do whatever side we want to find, right, over hypotenuse, right? So what is the side that we want to find? The side that we want to find is our y value, and our y value is opposite to the angle that we have. So we're going to have to use sine for the y value. So it's going to be 6 sine 60, right? Because that's the angle that we have. And so can you put these into the calculator, Shreya?
Okay,
Please.
give me a second. I'm gonna pause the recording. It's gonna take me a while.
Okay. So I plugged these values into the calculator, and I got the following for each, right? I rounded it to 2 here, 5.2, 5.2. And so what we're gonna do is sorry, let me flip this real quick. We're gonna add our x values and add our y values, because that's technically, if we're gonna do the right triangle, that's technically what our values are gonna be. We're gonna add both of our x's and both of our y's. And so whenever we do that, our fy, right, because the total vector fy equals 8.2, same thing with vector f's x equals 8.2. And so how are we going to find our vector, like our vector itself, Pythagorean theorem, okay? Okay, excuse my horrible right triangle. So 8.2, 8.2 right here. And if both of these are the same value, what can we conclude, right? This is a 45, 45, 90 triangle. So this is our magnitude. If you want, you guys can put that in decimal form. And so we have that. What is our angle itself going to be? So we drew, so let me draw this vector nice and clean one more time, right? So this was our vector right here, right? Original vector. And we just found this vector, right? And we got that to be 8.2 root 2. And so what is this vector's angle, right? And so we know that this vector is a straight line, right? And we know that the vector's angle is going to be right here, right? Is that agreeable for all y'all?
Yes.
Okay. And we know that this is our negative, right? This is our negative F3. So we know that this is going to be on this side of our XY plane, right? And this is 120 degrees. And so this right here, what does this look like? If we're starting from here, this is going to be 180 degrees. All right, so how are you going to write that? Vector F equals 8.2 root 2. What are the units? The units are n at, sorry, my was all over the place, 180 degrees. There you go.